You guys, example 9. We are now shifting gears to the distance formula, but we're still working in the coordinate plane. And this problem is actually using the same points in this one, the A and the B, but now instead of finding the midpoint, we're going to find the distance of the segment. So get excited. Alright, so it says given the points A, which are located at 5, 2, and B, which are located at 3, -6, find the distance of segment AB. Alright, so this is our distance formula. We are going to be subtracting our x coordinates and squaring them, subtracting our y coordinates and squaring them, adding those bad boys together, and then square rooting them. And then we're going to be done. Guys, so the distance, we're trying to find the distance of AB. So I'm going to replace my distance with AB. So the length of AB is going to be the square root of all this stuff that we need to substitute in. But before we do that, I like to label my points so I know directly where they go in my formula. So point 1, I'm going to call x1, y1. Point 2, I'm going to call x2, y2. Alright, so our nifty formula says to do our x2 minus our x1, and we're going to square those bad boys. So my x2 is a 3. Minus my x1, which is a 5. We're going to square that. Then I'm going to add it to the y value squared. So plus my y value, so y2 is -6, minus my y1, which is a 2. And I'm going to square them. Alright, so when we do this, I like to simplify my parentheses with the squared pieces first before we move on. Okay, so this is going to be AB equals 3 minus 5 is -2, and eventually we're going to square that thing, so -2 squared, plus my second parenthesis, so -6 minus 2 gives me a -8, and then I'm going to square that thing, bam. Alright, so now let's start squaring things. So AB equals -2 squared, so -2 times -2 is +4. Alright, so it's going to be 4 plus -8 squared, so -8 times -8 is 64. And 64 plus 4 is 68. So AB equals the square root of 68, which that is not a perfect square. So that means we need to simplify our square root down. And if you think back to when we did quadratics, we learned how to simplify square roots. And how do we simplify a square root that is not a perfect square? You guys are so smart. We do a factor tree. Awesome. Alright, so let's write what goes into 68. So 68, something that goes into 68 is going to be 2 and 34. Okay, let's break down the 34. That breaks down into 2 and, let's see here, 17. Alright, and that will not break down any further, so now I'm looking for my cute little couples that I can circle. Remember, the cute little couples get to leave the house for the night, or leave our square root. Alright, and all the single numbers have to stay inside our square root. Okay, so let's see here. We look at the ends of the branches to figure out what our cute little couples are, which I spot a cute couple of 2s right here. For every pair we circle, only one hops outside of my square root. So the 2 is going to hop outside. And the only number left at the end of the branches, so the 34 is not at the end of the branch because it's underneath, or because it broke down. Anything that has the little breakdown symbol or has the little, breaks down into this and this, we don't use. So 34 broke down, so I don't care about that. And 68 broke down. So the only thing left is the 17, and my sad, lonely 17 stays inside my square root. So the length of AB is 2 root 17. And that's it, you guys. Wasn't that fun? So the length of this, which we know the square root is 68, the closest perfect square to 68 is 64. And the square root of 64 is 8. Alright, so we know that this is going to be a little bit over 8. Okay, so we have a 2 here, and the square root is 17. The closest thing to 17 is 16, and the square root of 16 is 4. And 2 times 4 is about 8. So we know that this is a little bit above 8. So the distance from point A to B is about 8 units, which is pretty awesome if you ask me. Alright, so that's it on example 9. Example 10 is pretty much the same thing, so if you thought you understood this lovely example, I recommend you try example 10 on your own. Awesome job, you guys.